Welcome you all in lecture number 32 of Engineering Mathematics 1 MTL 1025. In this lecture we are going to discuss what is the Cayley-Hamilton theorem. Okay. And evaluation of eigenvalue and eigenvector. So let us see what is the Cayley-Hamilton theorem. Statement of the Cayley-Hamilton theorem is every square matrix satisfies its own characteristic equation. Right? If A is a square matrix, what is A? A is a square matrix. Then determinant A minus lambda I equal to 0 is characteristic equation. Then A satisfy characteristic equation. A satisfy characteristic equation. For example, if determinant A minus lambda I equal to 0 is this one, okay, be the characteristic polynomial, then this is equal to 0 is the characteristic equation. A satisfy this characteristic equation, right? It means if we replace lambda by A, then A satisfy this equation, then right hand side is 0. Let us see example. See, A is this, okay, then so that A satisfies its characteristic equation and find A inverse. First evaluate the characteristic equation. What is characteristic equation? Determinant A minus lambda equal to 0. Subtract lambda from the diagonal entries, principal diagonal entries, 2 minus lambda, 2 minus lambda, 2 minus lambda, and evaluate the determinant of this. Okay, evaluate the determinant. Then determinant of this, solve it carefully. See, the determinant of this is this one. Then the Cayley-Hamilton theorem says that matrix satisfy this characteristic equation. It means A cube minus 6A square 9A minus 4I equal to 0. A satisfy this one. Then we have to evaluate A is given, then evaluate A square, A into A, evaluate A cube, right? What is this? A square into A. Now A cube, A square and A put here in this equation and solve it left hand side and so that it is equal to 0. Now then we can say that A satisfies its characteristic equation. Okay. Now see what is A square. A square is A into A. Okay, this is A square. Now A cube, A square into A, this is A cube. Now this A cube and A square and A put into the equation of the characteristic equation. Now say A cube minus 6A square plus 9A minus 4I, A cube, 6 into A square, 9 into A, 4 into I, and solve it, it is 0 0 0. Okay, 0 0 0 0 0 0. It means 0 matrix of order 3 cross 3, right? It means this A satisfies its characteristic equation. Now find the A inverse. Since this is equal to 0, so A cube minus 6A square 4A plus 9A is equal to 4I. Yes, this is equal to A cube minus 6A square plus 9A is equal to 4I multiplied by A inverse. A inverse into A cube, 6 into A, 9A into A inverse is 9I, and 4 into A inverse, I into A inverse is A inverse, right? Then what is A inverse? 1 by 4 a square minus 6a plus 9i. We know what is a square, we know what is a and what is identity. Solve this right hand side and find the a inverse. Okay, then this is a square 6a 9i. Solve this right hand side, right? We find this a inverse. Okay, next, test the consistency of the following linear system. This is the linear system. Now convert it into the matrix form. In matrix form it is converted into this form. Coefficient of x1 is 4 1 0, x2 minus 1 5 minus 2 0 minus 2 4. Okay, into x1 x2 x3. What is this? This is equal to 12 0 minus 18. Okay, now what is C? C is equal to A and augment with B. C is the augmented matrix, so this is C. Okay, convert this C into the echelon form, right? So R1 and R2 interchange it with this one and make this 4 0. This is 0. Now convert this 19 1. Okay, or convert this 19 1 or you make it 0, whatever, we have already discussed this, right? This is 0. So this equation is converted into this form. Now what is the rank of the matrix? There are 3 non-zero row. First non-zero row, second non-zero row, third non-zero row. It means rank of C is equal to 3. How many non-zero row in A? Leave this one, leave this column and see how many non-zero row in A? 3. Rank of A is equal to 3. Okay, equal to number of unknown. Rank of A equal to rank of C equal to number of unknown. Then, right? Then x1 is equal to x1 minus 5x2 plus 2x3 is equal to 0, and 19x2 minus 8x3 is equal to 12, and 60 by 19x3 is equal to minus 128 by 19, this one. Okay, and after solving this by back substitution method, x3 is equal to minus 128 19 into 19 by 60 x3, and putting the value of x3 in this one, evaluate x2 and x2 x3 putting here, we find x1. Okay. Now let us see next example. What is the characteristic equation of the matrix, and also find the eigenvalue and eigenvector of the matrix. Okay, see, A is given by this, then determinant A minus lambda I equal to 0. First find the equation. This one is determinant as matrix A minus lambda I. Now determinant, see, determinant of this is equal to 0. After solving this, right, we got this one. Find the value of lambda. Lambda is 1 2 2, so this is the eigenvalue of the matrix. Now let capital X is equal to x1 x2 x3, x1 x2 x3 be the eigenvector corresponding to lambda equal to 1. Now subtract lambda equal to 1 from the diagonal entries, principal diagonal entries. Okay, so this matrix is reduced into this form, right? Means A minus lambda into I is equal to into x equal to 0. Okay, then what is lambda? 1. Then A minus 1 into I into x equal to 0. This is this matrix. Okay, so convert this matrix into the echelon form. Replace third row and first row. Okay, replace first and third row. So this is already 0. Okay, so convert this element into 0. How you convert it into 0? R3 such that R3 minus 2 R2. Okay, multiplying R2 by minus 2 and add into the third row. Okay, this is equal to 0 0 0. So this system is converted into this form. 1 into x1 minus 2x2 minus x3 equal to 0. 0 into x1, 1 into x2 and 1 into x3 equal to 0. See here two equation, total number of equation 2 and 3 unknowns. So let us assume x2 or x3 is equal to k. Okay, let x3 is equal to k. x3 equal to k, then what is x2? x2 equal to minus k. Then what is x1? Putting x1, x2, x3 in this equation, then x1 equal to minus k. What is the vector? x1, x2, x3. So x1, x2 and x3. Now took minus k common, 1, 1, minus 1. Okay, so this is the vector. This is the vector corresponding to lambda equal to 1. Okay, again let us assume x1, x2, x3 with the eigenvector corresponding to lambda equal to 2. Either you assume x1, x2, x3 or you can assume y1, y2, y3, whatever you want. Okay, convert this system into the echelon form. Right, after converting it into the echelon form, we find this equation. So in this equation x3 is 0, then x1 minus 2x2 is 0, x1 minus 2x2 equal to 0. Then what is x1? x1 equal to 2x2. Okay, so what is our vector? Our vector is x1, that is 2x2, x2, and what is third element? x3. What is x3? x3 is 0. 2x2 is common, then 2, 1 and 0. 2, 1, 0 is the vector corresponding to lambda equal to 2. This is the vector corresponding to lambda equal to 2. Okay, so the only one vector corresponding to x2, right, corresponding to the repeated. What is lambda? Lambda equal to 2 is the repeated eigenvalue. Since our eigenvalue is lambda equal to 1, 2 and 2, this is repeated. For repeated eigenvalue we got only one vector, 2, 1 and 0. Okay, hence our vector is 1, 1, minus 1, and write this vector 2 times, 2, 1, 0, 2, 1, 0. Okay, now see, this is homework for you. This is a matrix. A matrix is given, then find its eigenvalue and eigenvector. No, same way, that just like above example. Then what is lambda? Convert this into a minus lambda I. Subtract lambda from the principal diagonal element. Principal diagonal element is 2, 2, 1. Subtract lambda from there, 2 minus lambda, 2 minus lambda, 1 minus lambda, and solve it. Right? Then after solving it, we got lambda equal to 1, 1 and 3. This is the eigenvalue. And again, you proceed in the same way. Let us assume x1, x2, x3 with the eigenvector corresponding to lambda equal to 1. Then 2, 1, 0, 1, 2, 0, 1, 1, 1, and multiplied by x1, x2, x3. This is a minus lambda I. We have to evaluate a minus lambda I into x equal to 0. What is lambda? Lambda is equal to 1. So subtract lambda from diagonal element. Okay, and this is equal to 0, 0, 0. So this one 1, 1, 1, 1, 1, 1, 0, 0, 0. Okay, so this one is x1, x2, x3 equal to 0. This 0 is a vector, right? Now r2 minus r1. After converting r2 minus r1, what we get? After converting r2 minus r1, we get 1, 1, 1, 0, 0, 0, 0, 0, 0 multiplied by x1, x2, x3 equal to 0. It means x1 plus x2 plus x3 equal to 0. Here one equation. See, this is one equation and 3 unknown. Okay, so assume 2 as a arbitrary constant. Let x2 equal to k1 and x3 is equal to k2. Then what is x1? x1 is equal to minus k1 minus k2. Then what is our vector? Our vector is, see, x2 is equal to k1, x3 is equal to k2, x1 equal to minus k1 minus k2, And what is our vector? x1, x2, x3, and this is equal to, what is x1? Minus k1 minus k2. x2, what is x2? x2 is k1. What is x3? That is k2. Okay, so write it in this way. K1, coefficient of k1 minus 1, 1 and 0, plus k2, coefficient of k2 is minus 1, 0 and 1. So for lambda equal to 1, the vector is minus 1, 1 and 0 and minus 1, 0 and 1. So this lambda equal to 1 is the repeated eigenvalue, and we got two vector here. But see, in our previous example, for repeated eigenvalue 2, we get one eigenvector. Okay. Similarly, we can evaluate the eigenvector corresponding to lambda equal to 3. Right? This is homework for you. Evaluate lambda eigenvector for eigenvalue lambda equal to 3.